Hello and welcome back to Advent of Cyber. This is day 23 and it's going to be AWS Security Secret Santa. So the story for today is one of our stealthiest infiltrated elves managed to hop their way into Sir Carabane's office and lo and behold, discovered a bundle of cloud credentials just laying around on his desktop like forgotten carrots. The agents suspect these could be the key to regaining access to TBFC's cloud network. If only the poor hare had the faintest clue of what the cloud is, he'd burrow in it himself. Let us help the elf utilize these credentials to try to regain access to TBFC's cloud network. Today's learning objectives are learn the basics of AWS accounts, enumerate the privileges granted to an account from an attacker's perspective, and familiarize yourself with the AWS CLI. So it wants us to start our machine. We've already done that. Here we can see here, AWS accounts can be accessed by programmatically using the access key ID and a secret access key. For this room, both of these accounts will automatically be configured for you. The AWS CLI will look for credentials in the AWS directory, where you should see something similar to the following. Amazon Security Token Service allows us to utilize the credentials of a user that we have saved during our AWS CLI configuration. We can use the get caller identity call to retrieve information about the user we have configured for the AWS CLI. Let's run the following command. Okay, so let's open up our terminal. And we're going to run AWS get caller identity. And we can see here we have a user ID, an account, and an ARN. Seeing the output, the elf was overjoyed. The credentials work, and as can be seen by the name at the end, they belong to Sir Carabane. The elf can now attempt to regain access to TBFC's cloud network using these credentials. So it says run the command. We already done that. What is the number shown for the account parameter? And that's going to be this number here. Alright, Amazon Web Services utilize the Identity and Access Management service to manage users and their access to various resources, including the actions that can be performed against those resources. Therefore, it is crucial to ensure that the correct access is assigned to each user according to the requirements. Misconfiguring IAM has led to several high-profile security incidents in the past, giving attackers access to resources they were not supposed to access. Companies like Toyota, Accenture, and Verizon have been victims of such attacks in the past, often exposing customer data or sensitive documents. Below, we will discuss the different aspects of IAM that can lead to sensitive data exposure if misconfigured. IAM users. A user represents a single identity in AWS. Each user has a set of credentials, such as the passwords or access keys that can be used to access resources. Furthermore, permissions can be granted at a user level, defining the level of access a user might have. So groups. Multiple users can be combined into a group. This can be done to ease the access management for multiple users. For example, in an organization employing hundreds of thousands of people, there might be a handful of people who need write access to a certain database. Instead of granting access to each user individually, the admin can grant access to a group and add all users who require access to that group. When a user no longer needs access, they can be removed from the group. An IAM role is a temporary identity that can be assumed by a user as well as by services or external accounts to get certain permissions. Think of Sir Carabane and how, depending on the battle ahead, he might need to assume the role of an attacker or defender. When becoming an attacker, he will get permission to wield his shiny swords, but when assuming the role of a defender, he will instead get permission to carry a shield to better defend King Malware. IAM policies. Access provided to any user, group, or role is controlled through IAM policies. A policy is a JSON document that defines the following: what action is allowed, on which resource it's allowed, under which conditions is it allowed, and for whom it's allowed. Consider the following hypothetical policy. So this is a test policy here. Allow specific user access to read files only. Effect, allow. And the resource that they have access to is the private bucket. This policy grants access to AWS user Alice, which is the principal, to get an object from an S3 bucket. For the S3 bucket, name my private bucket. So it says what IAM component is used to describe the permissions. So it's going to be action. So it's going to be policy. So enumerating users. All right, let's see what we can do with the credentials we got from Sir Carabane's office, since we already have configured them in our environment. We can start interacting with the AWS CLI to find more information. Let's begin by enumerating users. We can do so by running the following command in the terminal. So we can do this again, AWS IAM list users. And we can see again, cybersecurity is here. We can see the created date, we can see his user ID and the path. Great, we can see an inline policy in the results. Let's take note of its name for later. So now, enumerating user policies. Policies can be inline or attached. Inline policies are assigned directly in the user or group role profile and hence will be deleted if the identity is deleted. These can be considered as hard-coded policies as they are hard-coded in the identity definitions. Attached policies, also called managed policies, can be considered reusable. An attached policy requires only one change in the policy and every identity that policy is attached to will inherit that change automatically. Let's see what inline policies are assigned to cybersecurity by running the following command. So we can run this for him and see what he has access to. So he has his own policy called cybersecurity policy. Let's take note of its name for later. Maybe cybersecurity has some policies attached to their account. We can find out by running the following command. So let's go run this one. And we actually don't see anything there, but we see he has a policy. So it says, not much there. Perhaps we can check if cybersecurity is part of a group. Let's run this command to do that. So now we'll check him for groups. He's not in any groups. Looks like cybersecurity is not part of any group. Let's go back to the inline policy we found for cybersecurity's accounts. Let's see what permissions this policy grants by running the following command. Replace policy name with the actual policy name you find. So this cybersecurity policy, let's go here. And we're going to check for this specific policy he has. We're going to delete policy name here and replace it with cybersecurity policy. And we can see these are all the actions that he has access to within his own custom policy, such as listing users, listing groups, list roles. He can get user policy, he can get role policy, get group, list groups for user, and more. So it looks like cybersecurity has access to enumerate all the different kinds of users, groups, roles, and policies. But that's about it. That is not a lot of help getting TBFC's access back. We might need to try something different to do that. If you look carefully, you'll notice cybersecurity can perform the assume role action. Maybe there's still hope. What is the name of the policy assigned to cybersecurity? So let's scroll back up for that. His policy is cybersecurity policy. The assume role action we previously found allows cybersecurity to assume roles. Perhaps we can try to see if there's any interesting ones available. Let's start by listing roles in the account. So let's do AWS IAM list roles. So we can see there is a bucket master role. There is a assume role here. But yeah, we can see there's a bucket master role. And it can be assumed by cybersecurity. Let's find out what policies are assigned to this role. Just as users, roles can have inline policies and attached policies. To check the inline policies, we can run the following command. So let's go ahead and run that. So Bucket Master has its own Bucket Master policy. So we can check what policies are included in that. And it looks like there is none. Looks like we only have the inline policy assigned. Let's see what permissions. And we can see here that there's a few different actions. We can list buckets and we can get objects. Well, what do we have here? We can see that the bucket master role can perform 3 different actions: list all, list bucket, get objects on some resources of a service named S3. This might just be the breakthrough we were looking for. More on this service later. So to gain privileges assigned by the bucket master role, we need to assume it. We can use AWS STS to obtain the temporary credentials that assume us this role. So we're going to need to run this command here. So it says assumed role user, which is cybersecurity here. And we are now have this role with this temporary access key. It also has an expiration, so letting us know that it's only temporary. So the output will provide us the credentials we need to assume this role, specifically the access key. secret access key, and session token. To be able to use these, run the following commands in the terminal, replacing the exact credentials that you received on running the previous command. Once we have done that, we can officially use the permissions granted by Bucketmaster role to check if you have correctly assumed this role. You can once again run the identity role. This time it should show you are now using the Bucketmaster role. So we're going to need to go ahead and export the access key ID. Might need to just do it this way. Might be a little quicker. We've exported that one. Now let's do the secret access key. And now let's do the AWS session token. And now we can do AWS, STS, get caller identity. Okay, I did that wrong. AWS, STS, get caller identity. And now we can see assumed role, Bucketmaster. So we have done that correctly. So the next question says, apart from the get object and list bucket, what other option can be taken, assuming the Bucketmaster role? So here we can list all my buckets. And there we go. So part 3, what is S3? Before we continue, we need to know exactly what is S3. Amazon S3 stands for Simple Storage Service. It is an object storage service provided by Amazon Web Services that can store any type of objects such as images, documents, logs, and backup files. Companies often use S3 to store data for various reasons, such as reference images for their website, documents to be shared with clients, or files to be used by internal services for internal processing. Any object you store in S3 will be put into a bucket. You can think of a bucket as a directory where you can store your files, but in the cloud. Now let's see what our newly gained access to S3cret S3 bucket provides us. So since our profile has permission to list all buckets, we can list the available S3 buckets by running the following command. So we can do AWS S3 API list buckets. And I spelled that wrong. And there we go. We can see one for a bunny website. We can see Easter secrets. There is one interesting bucket in there that references Easter. Let's check out the contents of this directory. So it looks like here we can see a groceries.txt file, and we can see a cloudpassword.txt file. That looks interesting. It says, let's copy the file in this directory to our local machine. This might have a secret message. So to pull that cloudpassword.txt, we're going to need to run this command. So it's going to download that locally on our machine. And there we go. If we do ls now, we will see the cloudpassword.txt, and we can go ahead and cat that. And now we can see a flag, more like S3cret. So let's go ahead and copy that. And it looks like that's the last question, so let's see. And we are done. This has been day 23. If you enjoyed watching the video, please hit the like button, please hit the subscribe button, and tomorrow will be the last day, and I will see you then.